So I would like to first thank for the opportunity to give this talk and to present our work that we do at Nova. So, a bit of introductions. I'm Pedro. I'm a computer PhD student at Nova University of Lisbon. I am advised by João Leitão. My topic is on enabling generic computations at the edge. I'm interested in peer-to-peer networks and distributed systems and algorithms in general. And we have been collaborating with PL for the past year, I think, and we started working with them on a multi-level DHT, and then we just continued on doing measurements on IPFS. But today, what I want to talk to you about is about building distributed systems and applications, which is most of the work that we do in our laboratory. This is the outline for my presentation. I'll present you a brief motivation. I'll give you some context. I will then present our tools, which is Yggdrasil and Babel that we're using there to build protocols. I'll also give a little bit of context on our experience with P2P and a small conclusion. So the first thing is that there's a growing interest in distributed applications. Like everyone here probably has interest in this, in peer-to-peer applications and distributed applications. But distributed applications are fairly complex because you need to coordinate a lot of nodes and you require many distributed services. And when you look at it, distributed applications are actually composed by multiple distributed protocols. So if here we have an application that wants to perform some networking, and usually what you would have in a simple example, you would need some messaging service that your application uses to exchange messages between applications. And this messaging service will probably need some protocol that gives a system membership that keeps tracks of nodes that are running the application. And your application can be as complex as you want, so you could have multiple messaging services that use multiple system memberships that talk over the network. And we could show a bit on very simplified architecture on IPFS, where you'd have IPFS is using bitswap to transfer data, and bitswap is also using the Cademia DHT to find nodes that have the data. So, as I was saying, distributed systems require complex implementations that need to deal with multiple aspects that relate to networking and concurrency usually. And at the lab, what we usually do is we first design the protocols that we want, we then implement, and then we evaluate them. And usually designing protocols, doesn't take much time. Implementing them is usually a hassle because there are a lot of multiple things that can happen in between. And then evaluating, it really depends on what we are trying to do, but usually it doesn't take as much time as implementing. And after this, we have to do this all over again, sometimes because we find that something doesn't work, sometimes because we want to design multiple and evaluate multiple different protocols to try to publish a paper, and then keep going over again, because that's what we want to do, is to publish papers. So to sum up, we want to build protocols that extract performance and with the least amount of time, so we want to be quick. And there are a bunch of libraries and frameworks and tools that actually exist, P2P included. And I'm going to talk about these two, which are Yggdrasil and Babel, that we developed at Nova. So Yggdrasil and Babel are frameworks to develop distributed and decentralized protocols and applications. And Yggdrasil is a C-based programming language framework, which is tailored for wireless ad hoc environments, while Babel is a Java programming framework, which gives you a more general and clean API to build more complex applications. And the goals of these two frameworks is to implement protocols as close to pseudocode specification. So it would be easy to go from design to implementation, and then to enable developers to focus only on the protocol logic, so you don't have to deal with all the aspects that go around. It needs to be simple to understand, so anyone could use it with a fair bit of knowledge. And at the same time, it needs to provide efficient real execution. But first we need to talk a bit about how are protocols modeled. So protocols are usually specified in pseudocode, in a mathematical language. And the protocol is usually defined as having a state that evolves by processing events, and protocols need to have event handlers that then manipulate or expose the protocol state. And protocols then can process any number of arbitrary events, but we characterize 3 types of events. We could have network messages that are events that are generated from and to other protocols in other processes. Timer events that are local events that represent the passage of time, and that can be periodic or a single action, say for example a timeout. And there are local events to enable different protocols to coordinate, search some kind of an internal API, you'd say, of the application. And these we can divide these in 2, which are request and reply events, which expose or define a one-to-one interaction between protocols, or notification events that define a one-to-many interaction, sort of an internal pub sub in your process. So going back to our tools, and again showing you our goals. The question is, so how do we implement protocols in these frameworks? And the simplest cookbook is you implement the state, you implement the events, and you implement the event handlers, and you're done. This is your protocol. So to give you an example, I designed a very simple ping pong application that periodically tries to ping a random peer. And when you receive a ping message, you reply with a pong. And once you receive a pong message, you just take the RTT that you got. So the code that I'm about to show you is not written in any of these frameworks. It's pseudocode, but it's very similar to both frameworks, removing all the C and the Java thing. Okay. So the first thing that I have here is the protocol state. I hope you can see it. If not, I think that's fine as well. So here the protocol keeps a list of the peers it knows. The second thing is the protocol is the messages and the events. So here I have 2 messages that keep a timestamp field, which is a number, and we have 1 timer event. And then we implement the protocol handlers. As you can see there, I mean, handling a message is you receive a message, and you say from which nodes or which peer you got it from. And on a timer event, which is a smaller one, which is the lowest one, you see that okay, you receive the timer event, you pick a random peer, and you just click or you just call the API function to send that message to that peer. And the framework should be able to handle everything without you worrying about it. And we also have a special event, which is the init, So we need to state what does the protocol need to do when it first starts up. And this is our protocol. It's very simple, no complex stuff. And in each framework, it's roughly like this. So the second question is, how are they executed? So we have our protocols, now we want to execute them. And the quick answer to this is that we execute each protocol in the context of a single execution thread. So inside the protocol, you don't have concurrency unless you specify that concurrency. Each protocol is assigned an event queue so that protocols can interact among themselves asynchronously. And then each framework core ensures the correct event delivery inside the protocols that execute in the same process. So to visually represent this, here you'd have a process that runs protocol A, B, and C. On the right-hand side, you have the core of the framework, and below the networking part of the framework. So protocols would use the API of the core process to send events. The core would put events on protocol event queues, and then the core mediates protocol communication with the network. And this is a very simplified view of, or an architecture of Yggdrasil and Babel. And so what can we, or what could we learn from these frameworks on P2P? And for this, I bring you my personal experience with libp2p. And the good thing I think about libp2p is that it's great for building distributed applications and get people involved in P2P in general, although it would not be my first choice to build prototypes. And this is because when I tried to use libp2p, I found that it had too many parts to work with. It was hard to reason about the architecture that I wanted to build. And what made me really drop libp2p is that I found that it had hidden assumptions there. Because I was trying to build my protocol, and I was not expecting to have concurrency there, without me explicitly saying, I want to have concurrency there. And this might be because of my biased view, because from what I come from, and from what I'm used to, Yggdrasil and Babel give me clear guidelines for development and an architecture. It is very easy to switch or modify implementations, and it has very generic APIs that I could use. While libp2p, for me, it seems like it's just giving me, after a lot of thought and a lot of looking at the code base, it seems that it's giving me rather standard implementations and services rather than guidelines to build what I need to build. And so I spent a lot of time thinking about what to put in this slide, to be honest. But I think this is it. So what I would want for libp2p, for we to use it, and to get more people engaged with this, is that we definitely need more guidelines to building protocols. Because when I have protocols in libp2p, I don't know how do they interact. So do I need to do that, or does the framework or the library has something like that? How does that happen? The other thing is that I think libp2p should have truly pluggable implementations, because as I said previously, it looks more of a standard implementations rather than modules or pluggable things, because not everyone needs Cademlia. You could use other DHTs, other overlays. There are other messaging types of protocols and services, and etc. And lastly, if you have all these, then you should be able to add and remove protocols and services with ease to and from an application stack that uses libp2p. So you just have multiple applications that use libp2p with different kinds of protocols among them. And to conclude, I hope this presentation gave you, at least was interesting for you, or it could spur interest in you in our work. Yggdrasil was published in, I forgot the conference name, but it's SAC in 2020. You can see there you have an open version. There's a GitHub link as well. Babel, on the other hand, was now submitted to RDS 2020. You can also see a bunch of examples. And again, I want to thank you. If you are interested in this, please contact us. Those are the contacts of us. And I think that's it. I'm open for questions.
That's great. Thank you very much, Pedro. I bet there are questions, okay? So it's impossible not to have questions.
Two questions. One, which libp2p implementation did you use?
I was using Go.
Okay. And two, do you know other related projects like Yggdrasil and Babel, like other projects related to those?
Well, there were a lot of projects before. There were, if I recall correctly, there was Appia at first, which was also to build like protocol stacks. The thing about Appia was that each protocol stack was run on a single thread, and all events would have to cross over all the layers. And Yggdrasil and Babel provide a much more flexible approach to that. Before that, there are also, I think it's called Cactus, which is evolution of Coyote, which also on the same kind of idea of stacking protocols. Before that, I think ISIS and Horus, which are very, very old. Before that, probably Xkernel, but that's for, I think it's networking protocols, and I think that's
Is there with like Yggdrasil and Babel? Do they also give you like any sort of like coverage or like proof statements of the protocols you develop on them, or are they just like a compiler for?
There is no proofs for that. That could be something that could be built on or top or with it, and it could be indeed helpful. But they are more of they provide you the structure to build your protocol. They provide you a runtime as well, and then that gives you processes, and then we basically execute those processes to make our experiments.
Got it. Thank you. Really cool talk. Thanks.
Thank you.
Great. Any more questions? Like nobody? Okay, I have a question. Okay, so I'm not a developer. I used to be a little one. Do you think, can you think of a use case where you would still use libp2p and not Yggdrasil or Babel?
I think libp2p is better for applications at the wild. So what you want to do applications, and you want your application to be public, then you should definitely use libp2p. It has the things that you need to do there. For building stuff or in prototypes in the laboratory, there are things that we don't need. For example, peer IDs. It's a very cool stuff to have, but I could as well use the IP and the ports for that in laboratory.
Okay, great. Thanks a lot. Okay, guys, any other questions? Or if not, I think we can pass to the next next speaker, João Leitão. Thank you very much again. Pedro, thank you very much.